Okay, so we're starting unit 3 here now, which is on our dosage calculations. And this is the stuff that's really kind of the meat and potatoes of what we need to get out of here. We're going to start with something we mentioned a couple classes ago. We're doing ratio and proportion, and that's something called a dilution. Um, okay, sorry about that. So anyway, for dilutions, we have two things we're going to be looking at. We've mentioned some of these abbreviations before, but I want to go over them again. NS stands for normal saline. It can also stand for neutral solution. Basically, all it means is it's some sort of a sterile water. It has no medicinal value. So it is totally neutral. Then the other phrase we're going to use is we're going to use the term serum. Serum, again, can have several different connotations. It can be the medication itself. Let's get back down here. There we go. Serum can be a medication. It can be a higher concentration of the medication. We'll call it concentrate. Or it can be some sort of a bodily fluid, like urine or blood or anything like that. So that is the material. That's the part that we are interested in. That's what is active or active ingredient. So a dilution is a ratio like we had discussed before. And the ratio of dilution is parts of the serum of that active ingredient or that ingredient that's of interest to us to total part solution. So if I have a 1 in 6 dilution of, let's go blood in water. So that 1 in 6 is 1 over 6. The 1, remember, stands for the serum, in this case, the blood. The 6 stands for the total solution. So if we were mixing ingredients here to make this, it would not be 1 part blood and 6 parts water. It's 1 part blood and a total of 6 parts. So how many parts water are in here? 5. There we go. Because there's 6 total parts. One of them is serum. 6 minus 1 leaves us 5 parts that must be water. So we might ask a question like, how much urine is needed to make 200 milliliters of 2 in 5 dilution? So again, this is a 2 in 5. What does the 2 represent? The urine, or serum, and in this case, it's urine. The 5 is total solution, total parts. So now on the other side of this ratio, on this proportion, we have the 200 milliliters. Does that represent urine or total solution? total solution. So 200 milliliters goes down there. Now you'll notice there were no units here in the dilution because our dilution is a ratio. What that means then is on the other fraction in our proportion, whatever units go on bottom, those same units must go on top. And then we will cross multiply and divide. 2 times 200 is 400, divided by the 5 is 80. So there should be 80 milliliters of urine in that solution. What dilution is created when a 120 milliliter solution contains 72 milliliters of serum? So again, in our dilution, the top number is the parts of serum, and the bottom is the total parts. So yes, you're right. The 72 is the part serum that has to go on top. 72 milliliters. Now, I'd said before we don't have units in our ratios. Why would I put them in there? Because I need to make sure that I have the same units on bottom before I cancel them out. Now, the total parts has to go on bottom. Do we know the total parts here? 120 milliliter solution. That would be the total solution. Now we can divide out the milliliters. Those units, those same units are gone. 72 and 120 can both be divided by the same number. What's one of them? 2. 72 divided by 2 is 36. 120 divided by 2 is 60. They can still both be divided by 12, I heard someone say. 36 divided by 12 is 3. 60 divided by 12 is 5. So that is 3 to 5, or a 3 in 5 dilution. What dilution is created when (32 milliliters of blood is mixed with 96 milliliters of normal saline, neutral solution? So now again, our ratio here, our dilution ratio, would be parts of serum, in this case blood, the total part solution. Do we know the parts of the blood? 32 milliliters of blood. Do we know the total solution? 96 is, there we go. We have 96 milliliters of normal saline. We are adding that to the 32 milliliters of blood. So we're getting 32 milliliters on top, stays the same. 96 plus 32, 128 milliliters of total solution. Now the milliliters cancel out. What can both of those be reduced by? 2 right away, you can see, right? So that's 16 over 64. How about now? 4, 8. Let's do 8. 16 divided by 8 is 2. 64 divided by 8 is 8. One more step. divided by 2. So 1 out of 4. So that's a 1 in 4 dilution. So I might ask how much urine and how much normal saline are needed to create 360 milliliters of a 2 in 9 dilution. So I need 360 milliliters total. Again, let's look at our dilution. The dilution, the top number is the serum. The bottom number is total solution. Our numbers here are 2 and 9. Do we have anything in our problem that represents either one of those? 360 is the total solution. The 360 milliliters is our total solution. So now we can cross multiply and divide here to find our amount of serum. So 2 times 360 is 720. We divide by the 9, gives us 80. That unit was milliliters, so that's 80 milliliters. So we need 80 milliliters of urine. Now that only answers half the question. The rest of the question was how much neutral solution or normal saline. Find that, we're going to do what? Yeah, 360 minus the 80 gives us 280 milliliters. So 280 milliliters of NS. So 80 milliliters of urine, 280 milliliters of normal saline. We might ask, how much normal saline is required to create 90 milliliters of 5 and 18 dilution. Well, again, we have our dilution here. It's a 5 and 18. The 5 describes part serum. The 18 describes total solution. Does anything that we have in this problem describe either one of those? 90 milliliters, which is total solution. Now, the question is, this is going to give us the amount of serum. Is that what we're looking for? No, we're looking for the amount of NS. If we find the serum, can we find the NS? Yes. So it's not what we're looking for, but it will help us get to what we want. So 5 times 90 is 450 divided by 18 is 25 milliliters. So now we got to finish solving the problem, answering the question. 90 milliliters total minus 25 milliliters of serum gives 65 milliliters of normal saline. Now, in this problem here, there are other ratios we could have used that would have worked maybe a little quicker, a little simpler. we have that 5 and 18 dilution. There are other ratios implied by that. We talked about this a little bit when we did ratios, that some of these ratios have hidden ratios in them. The 5 and 18 is serum to total. What if I want the ratio of serum to saline, serum to NS? Well, how many parts of serum are there? 5. How many parts of saline would there be? There's 18 total parts, and 5 of them are serum. It would be 18 minus 5 will give you 13. So we have a ratio of serum to saline. And we also can have a ratio of saline to total. The total would still be the 18, and it'd be 13 parts saline. So in a problem like the one we just did, if we wanted to find the amount of saline from the total solution, we could have used the 13 over 18. The 13 now represents the NS, and the 18 represents the total solution. Now on the other side, my numbers stay there. On the other side, we had the 90 milliliters total. We could have cross multiplied and divided. 13 times 90 divided by 18 is 65 milliliters. Any questions? So for a 3 in 10 dilution, find the ratio of saline to total. So a 3 in 10 dilution is 3 in 10. 10 is serum, or sorry, 3 is serum, 10 is total solution. Well, we want saline to total. There we go. We keep the 10. The 10 is still the total. 10 minus 3 gives us 7 for the saline. That'd be your answer. Yep, 7 over 10 is the ratio of saline to total. For a 2 in 7 dilution, find the ratio of serum to saline. So this is 2 in 7. The 2 represents the serum. 7 represents total. We want serum to NS to saline. What's the top number going to be? The serum is going to stay 2. The saline will be 5. So it's a 2 to 5. Any questions so far? So what is the dilution created when 120 milliliters of normal saline is used to create 150 milliliters of solution. I'll give you guys a second in your notes to see if you can get that one. We're looking for the dilution created, and a dilution will be serum over total. Do we have either of those numbers? Yeah, the 150 is the total solution, 150 milliliters. The serum is not given, but we can find it from if out of that 150 milliliters, if 120 milliliters is saline, we subtract, that's 30. So the other 30 has to be serum. So our milliliters can cancel out, and we can divide both of those by 30. This is a 1 in 5. What is a dilution used for? Well, there's two things a dilution can be used for. One is when we go to use the limits of a meter. Yep. 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 The dilution, though, is always serum to total. Whenever it asks for a dilution, it's serum to total. So if we exceed the limits of a meter, an example of this is blood sugar testing. Most of your blood sugar meters have a limit of 800 milligrams per milliliter, depending on the meter you have. So if you take a sample and it exceeds that limit, or even if it's getting close to that limit, it's best to dilute it down and take a reading. So let's say we have a patient whose blood sample exceeds the limits of our meter. And so we dilute 20 microliters of blood with 60 microliters of normal saline. Well, first of all, what dilution is created here? It'll be blood over total. Remember, dilution is always serum over total. So we have the 20 microliters, and this is going to be 20 plus 60. So yes, 20 microliters over 80 microliters. Microliters cancel out. 20 and 80 will both divide by 20, gives me 1 to 4. This is a 1 in 4 dilution. This is the reason why we do dilutions this way, or one of the reasons why we do it as serum over total, because now we can use that dilution ratio to adjust our reading. So the meter now gives a reading of 213 milligrams per deciliter. Find the true level. To find the true level, we use the dilution ratio, a 1 in 4. Now we have that 213 milligrams per deciliter. Is the true reading going to be larger or smaller than that? Larger. We diluted it, so we shrunk it down. So the true reading is going to be much larger. So the 213 milligrams per deciliter has to go with the smaller number, the 1. So to find our true reading, we're going to cross multiply and divide. 4 times 213 is 852. Divided by 1 is still 852. That's milligrams per deciliter. So the true level there is 852 milligrams per deciliter. We're going to do a few examples of these, don't worry. So once again, we have a patient that exceeds the meter. Am I spelling exceeds right? Is it EED or EDE? I'm right? Okay. That's just it. After you write it so many times, you start to wonder, did I? So you exceed the meter. And so we're going to use 15 milliliters of urine to perform a 2 in 5. Well, 2 in 5 ain't going to work well. Let me adjust it. Let's do a 1 in 5 dilution. A 1 in 5 dilution. So let's start out there. The first question is going to be how much NS should you use? So a 1 in 5 dilution, remember, when I do dilutions, I always label them because it helps me keep thinking in the right direction. 1 is the serum, in this case the urine, and the 5 is the total solution. We know the amount of urine, but we're not looking for the total solution. So we're going to keep the urine. What we're looking for is the saline. So that ratio, still 1 part urine. How many parts saline? 4. 5 minus 1 makes 4. Right? So now on the other side, we have 15 milliliters. That is urine. That goes on top. And then we cross multiply and divide. 4 times 15 divided by 1 is 60 milliliters. So we will mix 60 milliliters of water with our 15 milliliters of urine. The result is 193 milligrams per deciliter. Find the true level. I had to give you that. That I gave you. So you diluted it. Now you have that dilution. Now you put it in the meter. This is what the meter spits out. So it's still the same problem. Now, which ratio are we using? Do we need the 1 in 4 or do we need the 1 in 5 to get the true level? The 1 in 5, we need the dilution. Now the 193, is the true level going to be larger or smaller? Higher, larger. Well, by diluting the sample, you're diluting the concentration, so you're going to get a lower level, a smaller reading. So the true reading is going to be larger. Well, it's just like if you take sugar water, right? So you put a cup of sugar in a gallon of water. So you've got a certain amount of sugar in there. If you take a scoop of that solution out and put it in another bowl and add more water to it, the real solution has way more sugar than that one you just made, right? Because you diluted it down with more water. So the real reading will always be more concentrated or a larger number than what you had after diluting it. So we're going to cross multiply and divide here. 5 times 193 divided by 1 is going to give us what? 965. Good. And that's milligrams per deciliter. It might be less confusing for you if we put the whole problem together at once instead of breaking it down step by step like that. So I'm going to give you a problem here. Again, we have a patient that exceeds the meter. Or we suspect they exceed the meter at least. So we are going to dilute 10 milliliters of blood with 20 milliliters of normal saline. After diluting the sample, the meter reads 284 milligrams per milliliter. Find the true level. Well, in order to find the true level here, the first thing we have to do is find the dilution used. The dilution, of course, will always be serum to total. And yes, how much serum, how much blood in this case? 10 milliliters, yep, to 30, very good. It's going to be 10 plus 20. Yep. Yep. Think of it like making punch. You're going to mix a gallon of Kool-Aid with a 2-liter bottle of soda. You put it together, it increases the volume. The total is found by adding them together. That's what's happening here. We've taken the blood and the water and we've mixed them together to get a total. So now we can reduce that. The milliliters cancel out. Both of those divide by 10. Perfect. To give us 1 in 3. So that is a 1 in 3 dilution. So then to find the true level, we use that dilution, 1 in 3. The meter gave us 284. Where does that go with the 1 or the 3? The 1. Because the diluted reading is always smaller than the true reading, so it has to go with the smaller number. So then we'll cross multiply and divide. 3 times 284 divided by 1 is 852, yes. Any questions there? Okay. I'm going to have you guys try one on your own here quick. So again, it exceeds the meter. So we are going to have 20 milliliters of blood diluted with 80 milliliters of normal saline. The meter reads 191 milligrams per deciliter. Find the true reading. I'm going to pause and give you guys a couple minutes to find this. See how you did. So the first thing we have to do is find what dilution was created here. The dilution is blood to total. Our blood is 20 milliliters. The total, yes, will be 20 plus 80. which is 100 milliliters. So we cancel out the milliliters, and yes, both of those can divide by 20, get a 1 in 5. So that's the dilution. So we use that 1 in 5 dilution with the 191 milligrams per deciliter, which gives us 955 milligrams per deciliter. No, not for these, no. Yeah. Other things we can use the dilutions for is for actually diluting another solution. Let's say we have a 40% solution. And we are going to dilute 50 milliliters of that 40% solution with 150 milliliters of normal saline. The dilutions will allow us to figure out what our new concentration is, what our new percentage is here. Unfortunately, we're out of time now for today. So I'm going to give you some homework. Page 130 through 132 in your book. Problems 1 through 37. The odds go over dilutions. When we pick up next week, we will talk more about these dilutions and how we can use those dilutions for figuring out the new percentage when we dilute a solution. And we'll go from there. This actually replaces that concentration, that mixture problems we did on the test today. If you mix 25% with 40%, what do you get? This actually replaces that. Okay, you guys have a great week. If you need more time to finish the test, please feel free to stay as long as you need to.